Hello everyone, my name is Jin. Today I'm presenting MUFASA Multimodal Fusion Architecture Search for Electronic Health Record. EHR is very different from standard dataset such as ImageNet and WMT translation data because it has multiple modalities. For example, it has contextual features such as age and gender. It has categorical features such as procedure code and medication code. It has continuous features such as blood pressure and heart rate. It also has clinical notes. It is longitudinal and sparse. It only generates the records when the patient visits the hospital. So multimodality provides both challenges and opportunities. They have different feature types and underlying distributions. They have different data generation process and measurement frequencies. Synthesizing complementary information across multimodalities helps human doctors. However, adding modalities naively risks model performance. This is our motivating example. We apply three different strategies for the standard transformer. On the left, for the early fusion, we concatenate all the modalities together and they go through the same transformer. On the right is the late fusion. Each modality goes through its own computation and we combine them at the end. In the middle is the hybrid fusion. Each modality goes through half transformer block and they concatenate together and go through another half transformer block. The table on the left shows we apply three different strategies of transformer on all modalities. On the table on the right shows we apply transformer to a single modality. So there are two things to notice. On the left table, we can see the hybrid fusion and late fusion outperform the early fusion. So it shows the fusion strategies plays an important role for the performance. Secondly, if you compare the first row on the left table and the first and third row on the right table, we can see even with more information, multimodalities, if we have the wrong fusion strategy, the result could be worse than the single modality case. So we propose MUFASA, the first multimodal neural architecture search for modeling the inductive bias of EHR data. We propose a novel search space and objective that jointly optimizes fusion strategy and modality-specific architectures. We empirically show the superior performance of the proposed search space and its learned models on public EHR data. For the experiment, we work on the mimic dataset, and we have two diagnosis code prediction tasks, CCS and ICD-9. For the baseline search, we compare it with the standard unimodal neural architecture search. For the learned model, we compare it with the transformer and evolved transformer. We run 200 CPUs for around 5 days. These are the best architectures learned. On the left is the unimodal architecture. You can see it is wider than the standard transformer. It tries to create a different perspective for the same concatenated input. This is because it is unable to process each modality individually. On the right, for the multimodal architecture, we can see it applies customized modeling for each modality, so it's scarcely parallel processing the same state. The continuous features on the left go through its own computation and apply late fusion with the other modalities. For the clinical nodes in the middle, it goes through its own computation and applies the hybrid fusion with the categorical data. For the categorical data, in addition to the hybrid fusion, it also have a right path applies the late fusion with the other modalities. So this is interesting. It learns to apply two fusion strategies for the same modality. This is the performance comparison among different model architectures, such as LSTM transformer and evolved transformer and unimodal architecture. Here we can see our multimodal search architecture outperforms all the other models. And we generalize the learned model from mimic CCS to ICD-9 task, which we are not search on. You can see the multimodal architecture also outperforms all the other models. And one thing to notice, the unimodal architecture, the result is worse than the transformer hybrid and the late fusion. It shows its limitation when the fusion strategy plays an important role. Thanks for listening. Please let me know if you have any questions.